Right, let's head back into those drugs. Seems to be a specific test for illegal steroids at 99% accurate when the drug is not present in the bloodstream, but only 96% accurate when the drug is in the bloodstream. So it seems pretty accurate. If there's no drug, it's going to be fairly good. 99 isn't actually that great. It's quite terrible. Not present. Okay, so our story here, because sometimes like with finance mathematics, useful just have an idea of that story. People are getting tested for an illegal drug. You've either got the drug in your bloodstream or you don't, and you might have the drug in your bloodstream or not, and then there's going to be a test, and that test may or may not be fairly accurate. So let's read through that again and think, how is that going to help us know how we're going to solve this question? Specific test for illegal steroids is 99% accurate when the drug is not present in the bloodstream, but only 96% accurate when the drug is present in the bloodstream. If 300 athletes are tested, of whom 20 are using the illegal steroid, find some probabilities. But it doesn't really matter what's asked here, because what we need to know here is that a useful way to do this is with a tree diagram. Reason, we've got kind of one of two things happening. Either the person has got the drugs in their bloodstream, or they have not got the drugs. So that's our starting point. Now, we're told that there's 300 people altogether, so our denominator is 300, and 20 are using the illegal steroid. So we've got 20 druggies and 280 not on the drug. So that's kind of our starting point, just to go, okay, well, now we've kind of got a basis and we know where to go. Then we can see, we're going to test people, or people are going to be tested, and they're either going to come out to have been tested positive, or they're going to come out and be tested negative. So whether they're using the drug or not, they're going to do the test, and that test is going to show that the test is positive or the test is negative. Now, there's a nice simplified version of what's going on, but this kind of is a useful way to start thinking about, the efficacy of these drug tests, and the same for testing for lots of medical things. So it says here that it's 99% accurate when the drug is not present. So if we look at those that do not have the drug, the probability that they're going to test negative, so it's going to be accurate, because this is an accurate one down here, is 99%. Now, we can just write that as 0.99. From finance maths, we're used to writing things as percentages here. If you wanted to, and you wanted to write this as 99 out of 100, because it's 99%, go for it. Those two things are the same. And no reason to suddenly think one is way better than the other. Okay, well, if that's 0.99, this is 0.01, or 1 over 100. Because, if you're not doing the drug, you're either going to test negative or positive. So it must be one of those, so the probability must add up to 1. Okay, then we're going to look at the other bit of the puzzle and say, wait a second, it's 96% accurate when the drug is present. So if there is the drug, then for it to be accurate, it should be testing you positive. So that one there is 96%, and I'm going to write that as 0.96. Again, if you wrote it as 96 over 100, great stuff. And because we're kind of mixing fractions and decimals here, but that's fine. So I definitely want to keep this as 20 over 300 or 2 over 30 or 1 over 15. I don't want to round off, that's for sure. So that means that over here, 0.04. So in other words, it kind of feels like these are the people getting away with it. They've got drugs, but they test negative. And these are the poor innocent people that are not doing the drug, but they test positive because, the drug test is not perfect. True story with every test, I guess. I don't know, any really 100%. What is the probability of an innocent athlete being tested positive for the steroid? So that's the one we're just talking about. You've not got the drug, but you test positive. Well, for these, we just need to multiply these, right? So we're going, this probability is 280 out of 300. That's the probability of somebody not doing the drug, times, because we're going along times 0,01 into that lovely machine, that one there, and we go 280 over 300, and we multiply that by 0,01, and we get 7 over 750, which is that thing there. Now that looks a little bit weird, like how do I write that number down? This ENG button for engineering helps you with scientific notation, so I seem to be going the wrong way, so shift that one, and I get it. Remember that 10 to the 0 is 1, so 0,0093. So maybe we can round that off to 0,01. That sounds like a good 0,01. Be guided by whatever your assessment says you need to round off to. But that ENG button's useful. Let's pop a little note there, ENG. So that's what that is. Okay, so part 2 of the question says, how many athletes will test positive for the illegal steroid? So now what we need to see is we've got 2 pathways to consider. We're seeing people that do the drug and test positive. So these are all the people who are going to get hauled to the side, right? Before maybe they get a second test. And they might not do the drug, but they're going to test positive. So if we add those 2 things together, we're going to get the probability of somebody testing positive. So let's start with that as a starting point and say, so we need to look at 20 over 300 times 0,96, or, so plus the other root, 280 out of 300 times 0,01. And so that we're going to go equals, calculator, my calculator is going to cover things up on the screen, so, but you've got them there, 20 over 300 times 0,96, and what do we need to do? Plus 280 over 300 times 0,01, and we get 11 over 150. In other words, that's the probability of picking somebody. So that's a number between 0 and 1. So if we want to see how many out of 300, in this case it works quite nicely because that's the same as 22 out of 300. In other words, 22 people out of 300 will test positive. Oh, I'm way in the way there. This is a nice number. There we go. It's like rewind. I've got that rewind somewhere. So rewind, but I didn't really write anything, so it's not. So we got 11 out of 150 is the same as 22 out of 300. In other words, there are 22 people that will test positive. But if these numbers didn't work out so nicely that you could multiply that by 2, all you would have to do is take this number here, let's say it was like some funny looking fraction, and say, well, that's the probability of kind of out of 1. So we just need to multiply that by 300 to give us our 22 people. So that's how many people will test positive, which maybe the further question would be, well, it seems like then, I don't know, some of those people are not going to be, this is just probabilities. I don't want to say 2 of those people definitely didn't have, because these are just probabilities that we're working with. But clearly this number's out. Interesting enough, let's leave it at that, shall we? Come on, where's our, I think we need to go back to the drugs.